Hey there, my name is Rohit Kumar, and today we are going to discuss another very important research topic, which is real-time operating system. So let's start. Here you can see that some of the basic flow diagram as well as the architectural flows, real-time operating system structure, and the ecosystem diagrams are presented. So you can have a basic idea that what sort of different technologies, the kind of different components could have been part of real-time operating system, and what are the different processes and the architectural components those are related to real-time operating system. Now, when we are saying this much about the real-time operating system, the one thing comes into mind that what exactly a real-time operating system is. So as per the Wikipedia information, it says that it's a type of operating system intended to serve the real-time applications. That's it. And point is quite valid because real-time operating system is nothing but that in real time, if you have lots of application, then according to applications, you do have different requirements. So do you have a particular configuration facility at your side to manage or to tune in your operating system according to your needs? If yes, then it's fine. If not, then you need to go and search for the suitable option. So in this way, point is that there are different sorts of processes and there are different sorts of applications which do have the different sorts of needs, and in this way the multiple requirements might be in the form of processing delay etc are there, and you need to satisfy all of these sort of requirements. Now coming to the concept of real-time operating system and the related needs, then there are different related points, means like the characteristics of the operating system, real-time operating systems. So in this the soft real-time operating system, there so you do have some flexible time limits to different metrics, and if you do have the hard real-time operating system, then all the metrics are supposed to be within the tight bounds, and that's why the definition comes a hard and soft. But when you have different sorts of these things, then what sort of different issues are there? Then obviously there are multiple issues related to the scheduling, related to the latencies. Then there are multiple different sorts of types of operating system, again in the category of soft real-time and hard real-time operating system. Okay, so you need to go and have a sort of things that what are the different core principles behind the design of these operating system. Like many are event driven, many are using the concept of time sharing, and in this way they are having some sort of scheduling and making the things to run in an efficient way. So in this way you do need to see that what are the different states of processes being run on the system, and what are the different algorithms which are the part of process. So the different operating system related issues like the process scheduling processes, then the inter-process communication, masking, enabling, disabling interrupts, etc. So in short, if I say, then the computer architecture and operating system, these are the core two subjects which are going to relate to this particular field. And if I say that the research is also a very much focus in this particular domain, then you should not wonder, because it is closely related with the concept of embedded system and IoT. In my two videos related to embedded system and IoT, research in the series of research topic and domain, you may go and find the things related to these things if you are interested in detail. Additionally, I'm going to say this because IoT is the future, as many of you know, and there the focus is on the connecting things. Things means the low power and the constraint devices. Now, the point is that can you achieve it without the help of operating system, proper operating system support, means the right kind of real-time operating system or the kind of embedded systems? No. Obviously, you have to use the sort of embedded systems, some proper sensors, as well as you need to have the software component to run all these sort of things in the form of real-time operating system to meet the requirements in real environment. And you do see the future. And obviously, the point is that in future you do need the very low latency applications, and in this way, almost real-time operating systems are going to be the future. Now, coming to some of the very basic and the related topics related to this particular field, then these topics include the localization and mapping concept. This particular concept is also related to the domain of robotics, where we do hear about this particular term SLAM, simultaneous localization and mapping. Okay, so how this term comes forward, let me tell you. Localization means you need to the location of a particular thing, and in this way you localize a particular thing or entity. So if a robot is in a particular kind of environment, then the robot is supposed to firstly detect the things in its surrounding environment and then need to react accordingly. So point is that first you need to localize the things, then you need to build a global map of the relevant respective environment, and then you need to take the respective steps according to the built-in functionality or the kind of algorithm that is planted inside your ROM. So in this way you are supposed to function. But is it the only thing? Means is it the thing? No, obviously there are multiple APIs there which are giving you the continuous support to have the kind of localization and the mapping algorithms to run. Additionally, you have different sorts of sensor to recognize. Means the first point of contact is with the help of sensor only. Then you need to communicate to different sorts of processes to each other, so the scheduling of processes becomes very important. Then you have to have the real-time clock, because if you don't have a real-time clock, then how do they will have the proper kind of management of this simultaneous environment? Then you need to have a sort of microcontroller, because if robotic is not very big or sort of very complex system, then at least a microcontroller is needed to maintain these sort of services in a small environment. Then you do have the concept of networking, because multiple nodes are there, multiple robotic components or the multiple robots might be there in the environment, and in this way the nodes or the networking concepts come into picture. And all these things are related to operating system also, because everything is being controlled by a major operating system, and that major or the mother operating system is going to control the other, means kind of slave operating system or the other peer operating system, if you want to say. So in the concept of embedded system, concept of computer architecture, operating system, networking, all these things are going to come at a single place, and that's how you are going to have a particular product ready. So you can see that how powerful or how relatable, how impactful role of real-time operating system is. Okay, now coming to real-time operating system related more things. So the kind of platform that you are using, accordingly the operating system design has to be done. Then the virtualization support is definitely the major role of operating system, is to provide you a virtualization support, and in this way it's a virtualization related capabilities and the API support comes into picture. Then the right kind of memory management, because process management, memory management, the resources management, and the communication APIs management, all these things are the major responsibility of the underlying operating system. Then you need to have the sort of different hardware drivers, etc., and their management. All these issues are also managed by the operating system. So whatever, if you are related to the means, if you know very well about the operating system, then every sort of operating system responsibility comes on the shoulder of real-time operating system also, because ultimately it's a type of operating system. Okay, so hope you can understand that what are the possible aspects of research, what are the possible domains, so what are the interdisciplinary possibilities and sort of things. Now coming to the funding bodies and sort of relevant organizations. So almost every organization is related to operating system, because computer is present everywhere. But the people or the companies who are in the domain of IoT or the smart cities, smart infrastructure, smart medical, or the smart vehicular technology domain, then obviously they are related more, and you can go and have a search of these sort of companies or the organization, and then you can ask for funding. Coming to the citations, because the research is continuously on growth due to the embedded system, real-time operating system, and the IoT boom in coming and the futuristic era, then you should focus on some of the relevant journals where you can go and have a look or a search of the relevant papers. So I will tell you some of the related papers. First and the foremost is sensors. It's an MDPI journal, and there you can have the most of the sensor related things, and many of the real-time operating system related works have also been discussed in this particular journal. Then you have ACM transactions on embedded computing systems, then ACM SIGBED reviews, ACM SIGADA letters, then electronics, again the MDPI journal, then the ACM SIGOPS operating system review, then Journal of Sensors, International Journal of Online Engineering, IEEE Sensor Journal, and the International Journal of Advanced Robotics System, microprocessor and microcontroller. So all the things, means all the journals which are related to microcontroller, microprocessors, robotics, sensors, and sort of embedded system related journals. These sort of all things are related to the domain of real-time operating system, and obviously operating system related journals are by default there. means the architecture, components, and sort of process management, etc. Now coming to that, what are the different publishers? Because many times we do have a scenario that we are unable to publish with a particular publisher due to some reasons, might be very less journals related to your specific research domain, or your work got rejected from 2-3 specific journals of a particular publisher, then why not to change the publisher? Okay, so starting with the MDPI, you have the ACM, you have elsewhere IEEE, Hindawi, IOP Publishing, Springer, Sage, Telerin, Francis, and Wiley, etc. So you can go and have a check that what sort of journals are provided these many popular publishers, and if you don't find any, you may look for more. Okay, then additionally there are multiple institutions, and especially to have a better collaboration and the chances of wide recognition, you may contact with them. You can have a peer review team, and then you can go for publishing or creation of some useful research. Then you should have a look some of the related institutes which are publishing in the domain of real-time operating system. They are the University of California System, French National Center for Scientific Research, Chinese Academy of Sciences, Wuhan University, the University of Texas System, Carnegie Mellon University, CMU, Singapore University, University of California, Irvine, then the Shanghai Jiaotong University, University of California, Berkeley, Georgia Tech, Georgia Institute of Technology, then the CAGIFT, then Russian Academy of Sciences, etc. Additionally, the Indian Institutes of Technology and the National Institutes of Technology, Indian Institutes of Science, Engineering and Research, IISER, then IITs, Indian Institutes of Information Technologies, as well as the International Institutes of Information Technologies in India, are working and doing very impactful and good research in the field of embedded system, IoT, as well as in different operating system related research. So you can go and have a check on these sort of things, and you can have a group, or you can remain in contact with the relevant researchers to have the sort of discussions and to maintain your communications well. Now coming to the point of thing that when we have these many institutions, these many authors, these many different topics, then what is the output? So let me tell you some of the very recent published or the accepted to publish papers and the relevant impact with respect to technology and domain. So in International Journal of Research and Review, there is recently in 2022 work is accepted titled Overcurrent and Differential Protections for power substations using 3-winding transformers. Okay, so here you can see the protection means security sort of things come into picture. Then in scientific reports, an improved Lagrangian relaxation algorithm based SDN framework for industrial internet, a hybrid service flow scheduling is presented. And you can see again the crux of multiple technologies, like the mathematical modeling is there, then the SDN framework they have used it, then they are discussing an industrial environment, then they are discussing the hybrid service, and then they are discussing the concept of flow management. Okay, so in this way 4 or 5 different things they do come in a work, and obviously it is part because you need to discuss the architecture, then you need to discuss the specific flow graph of your work, then you need to discuss the technology that you are using, and ultimately you need to discuss the results in your work. Then in sustainability, which is I think MDPI journal, so they have accepted 2022 work, and title is Implementation of LoRaWAN, which is a type of IoT node, and here you can have the LoRaWAN based smart agriculture decision support system for optimal crop yield. Okay, so for the optimal crop yield means for the optimal agriculture production, they have used the LoRaWAN concept for smart agriculture, and they are using a concept of decision support system. Then in microprocessor and microprocessors and microsystems means, which is an elsewhere journal, there they have accepted a work in 2022 titled Compiler Assisted Energy Reduction of Java Real-Time Programs. Okay, so the real-time programs are part of real-time operating system, means they are designed for real-time operating system, and in this way it is related. Then in International Journal of Distributed Artificial Intelligence in 2022, they have accepted an embedded artificial neural network, means ANN based forest fire prediction case study of Algeria. So in Algeria, due to the fire incidents, they have discussed a sort of ANN based forest fire prediction system. Then the university cyber physical system prototype for predictive maintenance is discussed in the Bulletin of Electrical Engineering and Informatics, etc. So many things, so many different works have been in process, and there are multiple domains. As I always say that a product or the kind of technology is not a result of a single domain. It is always, or in mostly, at least in mostly cases, it is interdisciplinary. So multiple technologies or the domain come together and then you get a product in the actual form. So with respect to real-time operating system, there are multiple domains which are related, which are likely to be means the sustainability, microsystem, microprocessors, then the artificial intelligence, a distributed environment, the concept of informatics, networks, communication, electrical engineering, computer engineering, internet technology, sensor networks, and these whole lot sort of communication technologies as well as domains come together and realize the final product in some form. So that's why real-time operating system is also related to multiple domains and technology. Please do explore at your side. And after watching this video, if you think that some fact is wrongly presented or is not right, please do comment below, criticize the video, and let me know that how I can improve my videos further. I would love to hear from you. Thanks for watching this video. Thanks for watching again. Happy learning.